Okay, welcome to your first video lesson. This is for September 21st. So remember, the idea here is that you copy down the lesson over the weekend or possibly even Friday night. Don't bother doing any of the homework. I mean, you can if you want, but Friday or Monday when we come back, that full class is dedicated to doing the work assigned for this. So today's your last lesson actually, and it's for how can lines intersect. We took a look at this during your assignments that you did. This one too, you also have a handout. So for everything you see that I put up here, you're going to put on the handout that I gave you earlier in class. Our learning goals look at the three possible ways for how lines can intersect and use equation, graph, or solve. So we are going to consider three different systems: system A, system B, system C. So if you look at your handout, you have one block of squares at the top, one block of squares at the bottom, and on the back page a third block. So all of A goes in the first one, all of B goes in the second one, and on the back all of C goes on the back one. And we're going to compare y equals mx plus b form, slope, y-intercept, and number of solutions. So system A, graphically. Let's call this equation 1. Let's call this equation 2. First thing you want to do when you're comparing these systems is put them into y equals mx plus b form. Conveniently, they already are in y equals mx plus b form for us, so we don't have to do that. The next thing you want to do is compare their slopes. So if we look at equation 1, the slope is the number in front of x, so this has a slope of 2. And if we look at equation 2, it has a slope of -1. One thing you will notice is they have different slopes, and that's kind of what you're looking for, or at least one of the things you're looking for. The y-intercept for equation 1 is 1, for equation 2 is 7. Number of solutions, maybe we don't know yet. We will work on what the pattern is. So label your x, label your y, and then we're going to do some graphing. When it's written as y equals mx plus b form, the easiest thing, graph the y-intercept, then use your slope to get another point and connect them. So for equation number 1, our y-intercept is 1. Our slope is 2. Now remember, if it's written as a whole number, it's really over 1, so up 2 over 1, up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, and you can kind of repeat the pattern going the other way. And then for equation number 2, our y-intercept is 7. Our slope is -1. Remember, written over 1, so down 1 over 1, down 1 over 1. So down 1 over 1, down 1 over 1, we can already see our point of intersection. Connect them with a straight line. That was equation 2. That was equation 1.
Lauren Stratford to the office, please. Lauren Stratford to the office. Thank you.
Our solution, remember, is the POI, which in this case is 2, 5. The number of solutions, they only intersect once. So number of solutions, 1. So we proved it graphically. If you looked at the slope and y-intercept, which hopefully is the goal of doing it quickly, when we compare the slopes, they are different. When we compare the y-intercepts, they are different. If we have different slopes and different y-intercepts, that means there's only ever going to be one point of intersection. We are going to practice doing this using algebra. So if we take a look here, we've got equation 1, which was y equals 2x plus 1. Equation 2, which was y equals -x plus 7. That is best suited for substitution, sub 1 into 2. We have a y isolated, so we could put that in for that. So we're left with 2x plus 1 equals -x plus 7, 2x plus x, 7 minus 1, 3x equals 6, x equals 2. Now, since it's your first video lesson, just realize that if I'm going fast, you can pause it at any time, go back, have a listen, recopy. Because you can do that, I might be going a little bit fast now, but you can always just stop it and go back. Then sub x equals 2. Doesn't matter which equation you pick. Let's pick the first one. Y equals, replace x with 2. 2 times 2 is 4, plus 1 is 5. POI is 2, 5, which is exactly the same as we got when we graphed and when we compared the slopes and y-intercepts. So again, just proving what we're trying to figure out by comparing their slopes and y-intercepts. So all of that went into the first box. So you copied down the systems, you applied the mess with B form, put the slope, y-intercept, you did the graph, you did the algebra.
Maddie, office to the main office, please.
And then in the middle of that oval, number of solutions, you should have 1. So this is system number B. This is going, or letter B, I should say. This is going to be going in our second box at the bottom. Let's call this equation number 1. Let's call this equation number 2. Neither of those are written in y equals mx plus b form, so we got to change it. So starting with equation 1, we have negative 3y equals, I'm going to write it negative 2x plus 5, write it in the normal form we have, divide everything by negative 3. Y equals 2 negatives make a positive, 2/3 x minus 5/3. So equation number 1, y equals 2/3 x minus 5/3. Equation number 2, just going to rewrite it. Doesn't matter what side the y is on. 6y equals 4x minus 1. Divide everything by 6. Y equals, when you reduce that fraction, 2/3 x minus a 6th. When you're looking at the slopes, you should notice they're both the same. So 1 and 2 are both 2/3. The y-intercept for equation 1 is negative 5/3, and for equation 2, negative a 6th. So this is different from system A. System A, we had different slopes, different y-intercepts. Now we have same slope, different y-intercept. Let's see what happens when we go to graph it. You're going to have to kind of roughly guess, but so for equation 1, my y-intercept is negative 5/3, which is slightly under 2. So right there, up 2 over 3. So up 2 over 3. So something like that. And then take out your straight edge or ruler. Connect those as best you can. There's my equation 1. Equation number 2, negative 1/6, so like there, just under 0. Slope of 2/3, so up 2 over 3. Up 2 over 3, kind of like there. And if we do our best to connect those, there's equation 2. We can kind of see those are parallel lines. They have the same slope, a different y-intercept. Number of solutions, 0, none. Algebraically, if we look at both those systems, they're not set up nicely for substitution, so maybe let's appease the people that prefer elimination, and let's do elimination. So let's write them as like, we can write like negative 3y. When I bring the negative 2x over, it becomes positive 2x equals 5. And we have, that's my new equation number 1. And my new equation number 2, if I write it the same way, would be 6y minus 4x equals 1. Now that we have them lined up, our coefficients do not line up for any of them or do not match, so we got to multiply one of the equations by something. Let's say you want to get rid of the y's. We can multiply that by 2, that times 2, and that times 2. When you do that, you end up with negative 6y plus 4x equals 10. Don't have to touch the other equation. To get rid of the y's, would you add or subtract? Hopefully you guys are shouting out add. Negative 6y plus 6y gives 0y. They're gone. 4x plus negative 4x, that's gone. So we basically have 0 equals 10 plus 1 is 11. 0 equals 11. That is not a true statement. So we tried to eliminate the y's, we got rid of them. When we add, we had 0x equals 11. That's not true. 0 times anything should be 0. So if you run into that situation, that means, just like we proved when we graphed them, there are no solutions, meaning they do not intersect. There is no point of intersection. And finally, system C. So this is going to go on the back, everything together. Let's label this equation 1, this equation 2. If we want to change that to y equals mx plus b form, we're going to have negative 2, this is for equation 1, negative 2y equals negative 4x plus 6, divide everything by negative 2, y equals 2x minus 3. Number 1, y equals 2x minus 3. For equation number 2, we rewrite it y equals mx plus b form. 3y equals 6x minus 9. Divide everything by 3. We're left with y equals 2x minus 3. You should notice that we have the exact same equation. They just were multiplied by different coefficients. Slope, if we compare the slope, 1 and 2 both have a slope of 2. The y-intercept, 1 and 2 both have the y-intercept negative 3. Number of solutions, let's graph them and see. If I graph equation 1, negative 3, my y-intercept, my slope 2, up 2 over 1, up 2 over 1, up 2 over 1, and so on. Connect them with the straight edge, label that equation 1. Equation number 2. Y-intercept of negative 3. Slope of 2, 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Connect those with the straight edge. They are directly over top of each other. Now that doesn't mean there's no solutions, because remember solutions means, is there a point of intersection? There actually is a point of intersection. In fact, there's not a point, there is an infinite number of points of intersection. Those two lines cross each other everywhere.
Liz Newman to the office, please. Liz Newman to the office. Thank you.
So there are an infinite number of solutions. They cross everywhere. So when we were looking at system A, Different slopes, different y-intercepts, 1 point of intersection. System B, same slope, different y-intercepts, they're parallel, there are no solutions, they do not cross. Same slope, same y-intercept, same lines, they intersect each other infinitely number of times, which means there's an infinite number of solutions. What does that look algebraically? So equation number 1, 4x minus 2y equals 6. Rearranging equation number 2, 6x minus 3y equals 9. Those do not match. Let's say you want to get rid of the x's. 4 and 6 both go into 12. So let's multiply the top equation times 3 times 3 times 3. So our new equation 1 becomes 12x minus 6y equals 18. Our second equation, get that to 12 times 2 times 2 times 2. So our new equation number 2 is 12x minus 6y equals 18. If you want to get rid of the x's, you guys should hopefully all be shouting at me right now, subtract. 12x minus 12x, 0, they're gone. Negative 6y minus negative 6y, 0, they're gone. 18 minus 18, 0. Unlike before, and let's say we want to get rid of the x's, we can write 0y, 0x, doesn't matter. Unlike the last example where we had 0x or 0y equals 11, that's false. Here we have an actual true result. 0y equals 0, that's true. I can put in 100 for y. 0 times 100, still 0. So you have an infinite number of solutions, an infinite number of numbers you could sub in for y or x that still make it work. So this algebraically proves what we graphed, number of solutions, infinite, and y, because this is a true statement. The left side does equal right side. Anybody have any questions? Good, no questions. So, Monday, C work. Tuesday, Wednesday, review. Thursday, test. Friday of next week and Monday, you're going to get into unit number 2. Your homework, again, you don't have to do this. This is meant to be for Monday, but if you want to get a head start on it, you can. So page 59, that's for today's stuff. The test review, you should be doing that before the test anyway. And then when you come in on Monday, we can talk about the review, or we could work on the homework from page 59. Have a great weekend. See you on Monday.